Hello world and the SSG followers. So this is my 9 charging procedure. Let me show quickly what I have on this side. This is a voltage meter of the charging battery. Oops, sorry. Okay, you see here the charging battery. This is the voltage of my charging battery. This is a milliamps of my charging battery. I did not start my system yet. I will start it later, a little bit later. So on this side, what have you here? Voltage of my primary battery and the milliamps of the primary battery. Okay, I start my system like this. You hear this self oscillation noise. It's okay. I just need to disconnect one of the connections from my circuit, just like that. Then reconnect. Sometimes it needs a little bit time. Okay. So just reconnect and disconnect one of the connection cables of my circuit to the primary battery. And with further ado, I start my system just like that. Okay. Hope you can see my measurement equipment pretty well. So primary at 12.23, 1186 on the charging battery, and let's start charging procedure by moving one time the wheel. So you will start to see the milliamps and the voltage increase in my charging battery. So what I done differently this time I discharged my battery a few days ago. So normally I discharge my charging battery one day before I start my charging procedure, but this time I just did not get a lot of time and I just work like this. But you clearly see the voltage increase which I show you on my camera. So for the people who are watching this for the first time, you are currently watching a charging procedure by Bedini SSG simplified schoolgirl motor circuit, and it's charging the battery with short but very powerful impulses. You clearly see this on this side. Let me magnify this. You see 11.91. So one additional thing which I should mention, for discharging procedure I use one very simple device. This device always I connect this device always to the charging battery without any additional circuitry, and this simple device is just normal solar panel tracker device. It's like monitors the power load and power voltage of the charging battery, and this device I use separately from all this circuitry. And my device working like this. It's when I connect the load to this device and I connect the charging battery, the discharging procedure starts. So overall, why I'm telling you this stuff, I do not discharge to 11 volts. I discharge to that level which my device thinks the battery is discharged. So take it like this, and it's possible to calculate how much power I got and how much power consumed. But currently I not yet ready to release the Excel table with the overall charges and discharge procedures, but I will release it I will release the Excel table when I done with this charging and discharging procedures. So just have a patience. I know I have only one video per each week, but I do my best. And on this side, primary draw is at a very low current, like 29 milliamps. Power decrease. Well, about this primary battery. This primary battery was charged to 12.65 and a little bit higher to 13 volt, but the normal voltage which I currently get on this battery, this primary battery, it's like 12.43 volts for fully charged battery. But anyway, what I should tell you? I should tell you that voltage increase happening. So battery currently, this battery 12 volt 5 amp hour battery charging. I have two equal battery, but I charge second battery, which I call charging battery, with a high but very short impulses. And if you're not sure what I mean, just look my previous videos and you will get the understanding or get a view by which type of the current I charge my battery. But currently I do not use current, I use impulses. I produce impulses. How I know why I produce impulses? I just disconnect one of the terminals of the charging battery like this, and you see in here this you see this lighting bulb. This is actually a protection. It's 240 volts currently on this light bulb. And once interesting things, when I you probably it's out of zoom, I know. I probably tried to do my best. You probably don't. Oh, you saw some flashes. So it's like Bedini tells, some flashes can appear when you charge this battery by such type of the current. So yeah, it's like that. It's like that. And of course it's not a trickery, it's currently not a over unity system, I should tell you, because it's the way which I got my setup. I have my primary battery and I have my charging battery, so it's not a over unity system, because this primary battery will discharge due to the work which this battery put to charge another battery. But the way I charge the battery is not conventional way, by all the means. So to achieve over unity, in my understanding, I should build another circuit which will work with another two batteries. From this point I can go further and then switch two batteries for primary and charging purposes. I mean, like Bedini told in one of the videos, the way of thinking is to have two type of currents which are kept separately. And if I manage to cycle this changing of the batteries for non-conventional and for conventional type of charging, then I'm pretty golden. But I did not yet done my research on how to build such circuit, but I will just give you my thoughts anyway. But you see, my battery is charging pretty well, 11.96, and once again I just show you what's happening when I connect. probably you see some flashes appear. Not always. What happens when I disconnect another terminal? Hope. Okay, it's happening on my minus. It's happening on my minus. Some small flashes I don't see. Anyway, it's like this. It's like this. And another things which I want to tell you, I rewatched one of the Energy from the Vacuum video series, and Bidney told some interesting things which I supposed to tell you. In one of his videos he spoke about using capacitor to charging and discharging, and to use the capacitor to actually charge the battery. And I found very interesting what he told, that actually using capacitor is not very efficient way. I know it's like some confusing things, but I found this just very interesting, because he told that if you use a capacitor, a capped dam system, your capacitor temperature will at some point increase, and it's discharging, and using the capacitor for charging purposes and to use this charged capacitor to charge another battery, it's not very efficient, because you produce as a result heat, and heat means for me like power dissipation. So the system have losses, and my current system I can actually measure my losses, but what I can tell you currently, I see that my charging battery load during some time is increasing. So I have, say, all the same load, 250 milliamps for C20. I just test my measurements. I must use 250. Let me. Okay, 250 milliamps. Okay, I told right things. Sometimes I'm not sure. Now, 250 milliamps to discharge a 12 volt for 5-hour battery, and this 250 milliamps always happening. So what about I'm speaking? I'm speaking about how much current, how much load I can put on the charging battery to know what type of capacity has the battery. So anyway, I have some calculations done, and it's pretty reassuring, but I'm not ready to release my data about current discharge time of my charging battery. I will release the table in the future, but it's just it happens only when I'm done with my charging discharge procedures. But what I can tell you 100%, if my charging battery will further enlarge, when my capacity of my battery will increase, I can expect some things which I can only tell you that after the 20 charging and discharge procedure, I will stop charging this battery by conventional charging device, and I will hook up an inverter to the charging battery and try to use the power of the charged battery to charge conventionally the primary battery. Of course, it will happen separately from this circuit, so this circuit will be used only in one way, to charge this battery. But when I reach my 20 charging and charging procedure, I will start to use an inverter to the charging battery, and to inverter self I connect to inverter the conventional charging device and just try to charge this battery to full capacity. So that would be very interesting, and when the results are not promising, I will post this just like another experiment. And yeah, so it's currently pretty good, and 11.98. and what about other side? Oh, it's really too good, 26. Okay, so it's, you see clearly it can be charged. But let's look once again at the battery. Okay, sometimes you cannot see. Okay, probably. Okay, I just wanted to show you some flashes which I get when I connect this minus terminal. But anyway, this is all information which I can give you, but let's assure the charging by the impulse is actually working, and I hope to show you next time even better results. So see you next time. Thank you all. Bye bye.